Right, so now we can discuss the next most important module in the entire of maths, functions. But before I discuss that module, I want to bring up two study principles that you need to keep at the back of your mind as we progress with functions. Now, functions is an extremely important module because once I understood the importance of it, it was one of my major breakthroughs in maths. And so, everything that we've done in term one, every section that we've done in term one, we will apply functions to it. And so you would very rarely hear teachers talking about it, but I will be the first to tell you that every section that we've talked about in term one, we will apply functions to it. And so you do not take the topic lightly because we're talking about 3 months of the syllabus stems from this section. And so this is why it's so important. Now, as I've said repeatedly in the term one courses, is that numbers and variables can be very abstract. And so sometimes we need to see visuals. What are these numbers saying to us? Now, when we learn geometry, we understand shapes because we can see it. But when you look at numbers, it's very abstract. And so what the functions module does is it enables us to see what these numbers are trying to communicate with us, right? So let's talk about the two guiding principles that we should keep at the back of our mind when working with functions. And this applies to every module. This actually applies extensively to geometry, but I'm actually introducing it now so you can see it before we discuss the functions module. So these different squares talks about these different principles applied from a theoretical standpoint, from a real world standpoint, and what are some of the tips that you should think about when applying this principle. Right, so principle one, definitions. It provides us with a universal language that we can all use to communicate. What does this mean theoretically? So theoretically, why is definitions important? It is important in theory because it tells us what a concept is about. But more importantly, the constraints under which a concept can be utilized. So let's put this in a real world, from a real world standpoint. We often name things according to what we like. However, in order for us to have consistency, we have to follow a standardized way of understanding things. And so when you're learning the line graph, and when you're learning the parabola, and when you're learning the hyperbola, do not question the rule. It was created and defined in a specific way that we universally accept, right? So that's the reason why you need to study these things and learn the definitions of it, right? And then we can start challenging the rules once we understand it, right? What's the tip? When you're learning a topic, make sure that you understand your definitions thoroughly. And there I give an example that we've used in geometry. A square is a rectangle with two adjacent sides equal. This is one definition. And so if you're given a rectangle and you can prove that two adjacent sides are equal, then the shape is in fact a square. So we've already talked about that extensively in the geometry module. And so we will use this word a lot, by definition, in maths. And what it does is it says that you need to understand your definition. By definition, this is why we can use a specific statement. By definition, the line graph has the equation y is equal to x. By definition, the parabolic function has the equation y is equal to x squared. By definition, the hyperbolic function has the equation y is equal to 1 over x. So this is why you need to understand your definitions so that we can start building on these ideas. Then we move over to what we call standards. Now, standards and definitions are more or less the same. However, standards are like the foundational definitions for other concepts. So, for example, if you think of it like a building, the standards will be the foundation of the building. And then you'll have other things that will stem from the foundation that we give names and that we have to know the names of and what it means. But the foundation is what we need to understand more importantly. So theoretically, and this you need to listen to very carefully, standards are used for notations and for defining the foundation of a topic. And so if you look at it from a theoretical standpoint, notations, exactly like we said, that x squared, we call this what? The base, and we call this what? The exponent. It's the exact same idea. We call this a standard. So this notation is a standard, right? So it's a convenient universal framework for us all to follow so that we can communicate with each other. Take this exact same idea, go to any country overseas, it will still apply. So this is why standards are important. It's universally accepted, right? In terms of definition, why are standards important? Right, so this is an idea that's very specific to functions. So let's read. Working with topics like functions, we will talk about the parent function. This function gives a standard and meaning to the function in question. And so when you're learning the line function or the linear function, y equal to x is the parent function. And so you can take this function and you can shift it and you can stretch the function to form a variation of the function, but the parent function is the primary function. But what's more important is that if you change the definition of this function, then you change the function entirely. So you can't take this function here, right, the line function, and put a 2 here. By doing that, you change the function entirely. Now you have the parent function for the parabolic function, which is two different functions entirely. So we cannot change this definition, right? We can add numbers in front, we can add numbers at the to the right of it. That won't change the definitions. So this is why you need to understand what's the constraints when working with the standards. And so what I'm saying is y equals to x is the standard. It's the parent function. And then we could get variations. Y is equal to 2x. Or we could get y is equal to 2x plus 1. Those are variations stemming from a standard, right? In terms of notation, notation is important. It's a standard, right? It's a foundational definition for a topic, because the way your professor would write it is the same way your teacher would write it, and it's the same way a student should write it. And so this is why we have to understand the difference between definitions and standards. So standards, in terms of notation, is for communication, and in terms of definition, it provides the foundation for every other topic, right? Because there could be variations to the topic, but it all stems from where? This is what first principles thinking mean. We go down to the foundation, because it can't change here, but it can change here. But if we can understand the basics of it, then we can build our knowledge and understand much more complicated stuff.